Hi everyone and good morning. By presenting simulation part for electric simulation, first we need three resistors, which 0.6 millifarad, 100 kilowatt, yeah, R1, R2, here will be Rx. So we have to arrange it well, which probably. Second, we need variable resistors. See? Then after that we need battery source. After that we need DC emitter. Okay. Then we should to connect the wire for each elements. Now we should to put each value. R1 which 10 kilo ohm, R2 2.2 K, R3 which 5.6 K, R3 at 30 kilo ohm. Okay, here battery source, not different. 10 volt. Now we check probably everything. Now we have to change DC emitter to micro amperes. Yeah. Okay. Now we have to run for circuit simulation to get nearly 0 microampere or exactly 0 ampere. Now we have to do just the variable resistance. Okay, now we finally get 0.41 for DC emitter micro ohm, and that's it all. And thank you.
Okay, I'll be showing the simulation for activity 1 here. First, I extract all the components that I need. Resistors. We need 3 fixed resistors and a variable resistor. A battery source. Need a DC voltage source. And also an DC emitter. Okay, after extracting all the components, we arrange it properly. Okay, after arranging it properly, we connect the wire of every component. Okay, after connecting all the wire, we enlarge it, you can see properly. Okay, and we have agreed for R1 and R2, we have agreed using 25 kilo ohm. Our group have agreed 25 kilo ohm. For the emitter, we change it to microamperes. And our Rx, we have agreed using our last 2 digits of my metric number, which is my metric number 63 kilo ohm. And our R3, we have agreed our maximum for R3 is 70 kilo ohm, 70k. Okay, let's arrange properly. Okay, after our battery source, we have agreed using 10 volt for our battery. Okay, and next run it. This is the Wheatstone bridge, run it. Okay, for the Wheatstone bridge to be in balance condition, it need to be in 0 microampere. Okay, it shows that 90% of 70 kilo ohm, 90% of 70 kilo ohm for the R3, so that the emitter shows 0 microampere in balance condition. I'll be showing the simulation for activity 2 using the simulator designed by Virtual Lab. First, I set the voltage source to 12 volt and switch on the board and keep the switch as in short mode. Adjust the rheostat value to maintain the emitter reading set at 2 ampere. So 6 ohm rheostat value, maintain the emitter reading at 2 ampere. Next, set switch S to open mode and set the unknown resistance to 0.01 ohm. Then set switch S to bridge mode and set switch K to open mode. Set this 4 resistor value according to the table 5.4. So given is 1000 ohm for every resistor. And observe it shows that the millivoltmeter have 0 deflection. Now set switch K to close mode and maintain these two resistor and vary these two resistor to adjust it to 0 deflection. So it shows that RB at 983.5 ohm and R small letter b at 1001.2 ohm, the millivoltmeter at 0 deflection. 0 deflection is achieved, then we calculate the unknown resistance value. So the unknown resistance value is 0.00998 ohm.
So I'll present the activity 2 part 2 in this virtual lab. So first of all, for the volt, I set it to 12 volt and then on this in virtual lab. Then set the switch S to short mode Then adjust the rheostat to 6 in order to get the value of 2 on ammeter. Then set the switch S to open mode, and then set the low resistance to 0.05, and then set the switch S to the bridge mode, and then switch K to open mode, and then according to the table 5.4, set all the resistor to 1000 ohm. After that, you can see the millivolt meter have 0 deflections and the value is 0. So we set the switch K to close mode, and then we try to vary the 2 resistor B to get the 0 deflections on millivolt meter. So after adjusting R capital letter B to 996.3 ohm, and then the R small letter b to 1004 and 3 ohm, we successfully get the 0 deflections on millivolt meter. So after achieving the 0 deflections on millivolt meter, we press calculate the unknown resistor value, we get 0.00497. So that's all from me. Thank you.